Okay, so what I want you to do on number 7 and all the rest of these on the back is we're going to be combining stoichiometry with the gas laws. Okay, so let's look at the question that they're asking in number 7, and you have to think about, I'm only going to use a gas law for gases. You can't use a gas law for solids. So if they're asking you to find, say, the mass of a solid or something like that, you're going to have to convert your gas to moles, and then you can use your balanced equation to figure out anything else they ask you about. Okay, so the information that they're giving you that involves liters, temperature, pressure, that's all going to belong to the gas that's in your equation. Now, if you have multiple gases that are in your equation, say for instance like number 3, look and see what gas that they're telling you that they collected. Like on number 3, it says if the NO2 is collected at this temperature and this pressure, what's the volume? So when you plug that information into PivNert, you're going to be solving for NO2, all right? But you do have to be careful and say, well, where's my moles coming from? In number 3, the moles is starting out with nitrogen, so you would have to convert grams of nitrogen to moles of nitrogen, and then for moles of nitrogen, you would go to moles of NO2 using the balanced equation, okay? So let's use number 7 because that one was asked about earlier today. And so if we did we talk about one of these on Monday at all?
I think not.
Not, you think not. So we're going to use number 7 as our guide to help us out through this. Okay, so the following reaction forms 6.41 liters of oxygen at a temperature of 18.7 degrees Celsius and 731 torr. What mass of KClO3 must have decomposed? Now, as I'm working problems, even though I've been doing this for a long, long time, I still break down and analyze my problem. So I look at the things that I'm actually going to be measuring. I'm looking for this stuff, so I put a little box or circle around it, or sometimes I just underline it. And they're talking to me about oxygen, okay? So I know I'm dealing with those 2 substances in my balanced equation, and that's it. They didn't ask me anything about KCl. So it should not show up in my calculations at all, right? All right, so the information that they're giving us is all about oxygen right now because it's the only gas, and they actually said the following reaction forms this much oxygen, this is the temperature, this is the pressure. So I'm feeling PV equals nRT, PivNert, because we have pressure, volume, temperature, right? And we don't have anything else given to us. We could figure out number of moles from that, and R is going to be a constant. Are the units, though, in the correct form to use PivNert?
No.
So our pressure is in torr, our temperature needs to be converted into Kelvin. Okay, so remember, we're going to add 273 to this. What are we going to do to this torr pressure in order to get it into the proper units? Divide by 760. Good. I'm just going to kind of pencil that in right here. I'm going to need to divide that by 760. So go ahead right now, guys, and get all of your units converted correctly before we plug that into PivNert. Yeah, that's how many torr are equal to 1 ATM. We want to convert it to ATMs, Aisha. Okay.
Would it be easier to manipulate the right side of the equation because you can and then you could just do it for O2 and then you have
How are you going to find the mass of, oh, you're saying manipulate the right side of the equation? I think it'll take you, well, you could do it that way. You could do it that way. But in terms of ease, I think it'd be about the same. You'd actually have one extra step, Patrick, I think, because you'd have to, yeah, you'd have one extra step. Right. Would you divide by 2? It would be a 3-to-2 ratio, though. So I think it'd take you more steps to do it that way. Okay. So I'm going to go ahead and start plugging stuff in. Who has the pressure after you divided? Okay, so 0.96 is the pressure, ATMs. And then we're going to multiply that times the volume, which is 6.41 liters. equals N, we don't know. That's what we're looking for. Our R value is 0.0821 liters times ATMs over moles times Kelvin. And then our temperature, what do we have in for our temperature? 291.7, okay? And that's in Kelvin. Now, I deliberately put my units in here so you guys could see unit cancellation. I didn't do that on Monday, but you need to see that your units are indeed going to cancel. Look, Kelvin, doesn't that cancel right here? Okay, and then I'm going to move my two numbers here away from N, so I'm going to be dividing by 0.0821 times 291.7. That's all going to be moved over to this side of the equation. And that's liters times ATMs over moles right now, because I already canceled out Kelvin, times 291.7. Now, what units are going to cancel out? ATMs and liters are going to get to cancel. And I know we didn't practice on that on Monday, but it's good. You need to see that if you plug your units in, this is why we have to have our units this way, okay? We have to have our pressure in ATMs. We have to have our temperature in Kelvin. Our volume has to be in liters. Okay, so real quickly do your math and let's see what you find for your number of moles of oxygen. Really see that, can y'all? All right, so did you guys get that answer, if you can see that without the glare? 0.2569, but I got to round at some point. 0.257. Okay, so the number of moles of oxygen, just going to write that down here, 0.257 moles of O2, except they want the mass of KClO3. So now this is where the stoichiometry part comes in, okay? So I'm already in moles of oxygen, and I need to convert from moles of oxygen to moles of potassium chlorate, or KClO3. So look at your ratio. What do you have? 2 to 3, okay? Where's our 2 going to go, top or bottom here? Top. So for every 2 KClO3s, we have 3 O2s. That means O2 is going to cancel out. All right, and so for every 1 mole of KClO3, this is why you guys need to have an eyeball on the periodic table. Let's find the molar mass of KClO3. Yeah, it's kind of small, isn't it?
It's actually a molar mass of 39.0.
So you said 39 point. Okay. Okay, so I'm going to go ahead and write that down, and Malcolm, go ahead and give us the molar masses and we'll verify Aisha's number.
Okay, so just leave 1.2.
Okay, and so Aisha said 122.55, and she is correct. All right, so now we've got to run our numbers through our little mole train. Notice this was only a 2-stepper because we were already in moles. So we weren't going from grams to moles to grams. We were just going moles to grams, okay? So we're going to take our 0.257 times 2 times 122.55 and then divided by 3. So that's on the bottom. 21? Yep, I agree. Again. Say that again, Patrick. Would we only, okay, I see what you're saying. These two numbers are actually not, they're not like measurements. They're just part of your stoichiometry and your balanced equation. So those won't count as sig figs. It's only going to be your actual measurement would be this first number. The molar mass is not going to count in sig figs, and neither are your numbers there. So we do need 3 sig figs. So I'm going to call this 21.0 since that rounded to 21. And then this is grams of KClO3. Okay, so Sydney, I think you asked about that one. How did that answer all your questions with it?
Yes.
Awesome. Okay. All right. Now, you have to look at each individual problem to see how you're going to work it, because on this one, we used PIVNERT first, and then we did stoichiometry. I think on the ones that that you start with, you may actually use stoichiometry to get you started. Let's look at number 2, for instance. How many of you have done number 2? Raise your hand if you've already got that one taken care of. Okay, so then let's look at number 2 together, okay? And I'm going to let you guys tell me how to work this through. Okay, so the reaction uses 18.2 grams of copper 1 sulfide. Find copper 1 sulfide in your balanced equation and either underline it or circle it. It says, what volume of sulfur dioxide gas? So what's the other thing we're using in this balanced equation? Sulfur dioxide. Find sulfur dioxide in your balanced equation and either underline it or circle it. Okay, can you tell me right now what the ratio of those two things are to each other? It's a 1-to-1 because it's got a 2 and a 2 in front of it. Okay, so it says what volume of sulfur dioxide gas would be collected at this temperature and this pressure. And so we're looking for V. And so what gas law does it tell you? I mean, what does it kind of scream at you that you're using? You've got volume, you've got temperature, you've got pressure. There you go, because you only have one of them, right? So if you had like 2 pressures, 2 volumes, that would be, you're going to be looking at a different gas law. Maybe 2 pressures, 2 volumes would be, if that's all you had, that would be a Boyle's. If it's 2 pressures, 2 volumes, 2 temperatures, you're looking at the combined gas law. So you just look and see what fits, okay? So since we only had 1 pressure, 1 volume, 1 temperature, then we're dealing with PIVNERT. We're dealing with the ideal gas law. Okay, so I think, can we plug stuff into this, or do we have everything we need in the proper units? Okay, good. Lindley, we've got to change the temperature to Kelvin. So you guys do that real quickly in your calculator. And Olivia, be ready to tell us what the answer is in Kelvin for this number. You have your Kelvin temperature? What you got? 510, okay. So that's done. Is our pressure okay? It's in the proper units? Yes. All right. And then what else do we need? Volume, we're looking for that, right? We need the R, which is and we need moles. So do we have moles done properly? Not yet. So we need to take care of that, right? All right. So if I start off with 18.2 grams of copper 2 sulfide, what's my next step? Because this unit right here is in grams. So do we have anything in moles that we can plug into PIVNERT? No? Okay, so you guys, I'm going to let you guys tell me what I've got my setup started. What am I going to put in there? divide by the molar mass. So I need the mass of Cu2S. Really? I think it's a little heavy there. 159.17. Hey, Miss Reed, do you need he is. He's right over here. Yes, ma'am. Do you need me to take care of 7th and 8th?
Yes.
I can do that.
Coach Lee said, if you need him to learn so that you can hold the video, just text me.
Okay. All right. All right. Thank you, Miss Reed.
No, thank
You be careful. Okay. All right. So this is 1 mole. Do you need to see, Sammy? I'm sorry. Where do you want to see it? Just go wherever you need to see. That needs to be your spot. You're more than welcome to sit there. Okay. I don't want to keep you from vision. Okay, so I put 1 mole of the copper sulfide on top. Okay, now could I go ahead and do my math and then plug that moles into PivNert? Okay, so Malcolm's like, not sure. Okay, so you say, yes, I can plug that in? But we do actually would need to show that understanding, okay? That it is a 1-to-1 ratio, because if I just like, oh, okay, I'm done. What if it wasn't a 1-to-1 ratio and it was a 2-to-1 ratio? Well, you wouldn't fail the entire test. You just wouldn't get the total answer right. You would miss a point there, okay? So we're trying to plug in a gas into our gas law. So we do have to convert to our gas that we're looking for. We underlined those 2 things for a reason. So for every 1 mole of copper sulfide, and just for purposes to not confuse anybody, I'm putting a 2 there, okay? I know you guys said it was a 1-to-1 ratio. 2 to 2 is 1-to-1, so technically I could just cancel that out, couldn't I? But I've converted my units is the crucial thing. So grams of copper sulfide is out of here. Copper sulfide is out of here. Now I'm to sulfur dioxide, which is the goal was to get to sulfur dioxide. Okay, so Hesley, would you give us your answer when you divide that real quickly?
So what is it? 15.2
You say you got 0.11. Anything after that? Because we actually would need 3 sig figs. Got a 4? Okay. Now why I say 3, look at what we've got right here. That's our measurement. 18.2 was our measurement. Okay, and then this is moles of, you just converted that to SO2. All right, now can we plug this into PivNert? Yes, we can. So this becomes basic, just a basic gas law problem at this point. So our pressure is 10.7 ATMs. I'm not going to put my units because I'm kind of running out of room. Volume we're looking for, N is 0.114. Our R value 0.0821, and our temperature was 510 Kelvin. Let's see. So would everything cancel out but liters, Aisha? Okay, so yes, you'll be in liters. Okay. Now you guys are calculating, confirm or deny Aisha's answer. Actually plug that in your calculator and see if you agree with her or if you disagree. Okay, good, Haven. If you disagree then, Jasmine, do you agree or disagree with the number that I put up here for volume? You agree, okay. So we've got several agreements on the floor. I'm going to say that that would be our answer. Now, if you disagree, then you need to figure out how did I not get that answer, okay, like you guys have been doing. All right, we have worked 2 of these together. You've got to have some practice on it. The struggle is what makes it click in your brain, all right? That is what makes it click, Lucas. You got to do the struggle. If you don't do the struggle, I'm telling you, you don't get it. You have to push it. You have to push through and figure it out. It makes brain connections. It grows some new brain cells. grow some new connections. Those little brain cells are reaching out their little axions to make connections with other axions. So you're writing it on the wrong problem. It's okay. That's fine. That's fine. It's all good. Okay, so I'm going to box my little answer here. Now, last chance for questions before I turn you loose to your groups. Yeah, you're going to finish that, and then once you finish this, do make sure you turn in all your work that you've done with that. There is a kind of a review activity that mixes them all up, and it's on Kim Geek, so it's on your computer, and you'll do that before you leave. Just make sure you submit a screenshot of your final score there, okay? But it's just practice today. All right. So Tyler, click our lights, and you guys get busy practicing.